Hello and welcome everyone. Thank you all for joining us today for this live stream event. Before we begin, I'd like to go through a couple of items with you. Our code of conduct. So Microsoft Reactor seeks to provide a respectful environment for both our audience and our presenters. We encourage engagement in the chat, but we ask that you're mindful of your commentary, remaining professional and on topic. This session is coming to you live on YouTube, so it will be available afterwards on demand through the Microsoft Reactor YouTube channel. If you've not tuned in before with us, just note if this is your first time on a live YouTube session that you do need to have an account set up on YouTube to interact in the chat. So if you don't have that, now is a great time to set that up. Just in case you have any questions, we can get those answered for you. So today's session, we are joined by Brian Sam-Bodden of Redis. Let me bring our speaker up on the screen. Welcome, Brian. Thank you for joining us today. Looking forward to this event.
Thank you.
So Brian will be going through Face It, Your Cache is Your Database. That's a fun name. And this session will run for, correct me if I'm wrong, about 45 to 60 minutes, Brian, and time for questions?
Yes.
Awesome. So I will let you take it from here.
Perfect.
Have a great session. And thank you to our audience for tuning in.
All right. Well, hello, everybody. I'm Brian Sam-Bodden. I'm a developer advocate with Redis. And today I want to talk about Redis and how Redis as a cache really becomes your database, and why caching really it's an extension to the database that, for all intents and purposes is your database. All right, so the title of the presentation that you see on the screen, it's Beautiful Multi-Model Applications with Redis Stack. And why beautiful? Because I'm working with Spring Boot, which is a Java framework to basically build web services, full-blown web applications, distributed applications. So it's a very versatile framework. So again, I am bsb@redis.com. You can email me with any questions. You can find me on Twitter at bsbodden, and also bsbodden on GitHub, where there's a lot of my Frankenstein experiments you can take a look at. All right, so the premise of the session is that your cache is your database. Why do I say that? Caches typically started as a very simple premise. You put a key in a value, and then when somebody comes to basically ask for that data, instead of doing a round trip to the database, you do a trip to the cache, which typically it's in memory, which basically speeds up and helps you clear any bottlenecks that data access might be causing in your application. But caches went from being simple key value systems to being what I call them now, full multi-model, multi-data structure in-memory first databases. And when you see a cache like that, it's really just a database that happens to be in memory first. So your cache, it's your database because it's the first surface that your application is going to interact with. So if your cache becomes the thing that you're putting in front of all your critical, performance critical parts of your application, then your cache should probably be a real database. You don't want to limit those interactions with the cache to being simple key value requests. What if you could query the cache? What if you could get specific data structures out of that cache? What if you could put the data in the cache in the format that it's much more useful to your application? And that is where Redis comes into play. So for those of you that don't know what Redis is, it's definitely more than a cache. It started as a cache, but nowadays has evolved into much more than that. So let's start with a definition of what Redis, how Redis started. And it's a remote dictionary server. That's where the Redis name comes from. And it's an in-memory first optionally persistent. So one of the big misunderstandings about Redis is that when people think of Redis, the word caching comes to mind, and that leads you to the thought that the data is ephemeral, and the moment that that machine or that node goes away, that data is gone. And that is not the case. You can selectively decide whether you want that data to be persisted or not, just like a real database, just like most of the NoSQL databases nowadays can do. So Redis, it's in memory first. It's optionally persistent. So I see it more as a remote data structure server. Of course, that name will never fly with marketing. So let's move on. And why is it a remote data structure server? It's because you have multiple data structures built in that allow you that you can interact with. So your cache is not limited to name value pairs. That would be in this slide where you see at the top left the strings. But we also have in Redis bitmaps, bit fields, hashes, lists, sets, sorted sets, geospatial indexes, hyperlog, which is a probabilistic data structure, and we have streams, kind of like Kafka-like streams. But that is just the open source version or the core version of Redis. Redis can also be extended. And of course, did I mention that I actually work for Redis? Redis can be extended with the concept of modules. And modules are add-ons to Redis that give you new data structures and operations over those data structures. And this is how Redis has evolved from a simple data structure server, remote server, to a full-blown database. We have JSON. So we have Redis JSON, which turns Redis into a full-blown document database. We have Redis Search, which basically it's kind of like the magic glue that basically brings everything together and gives you a full-blown search engine, similar to Elasticsearch, in Redis. And it works with, for example, all the new data structures being added. There is a graph database called Redis Graph. There is a time series data structure with its associated commands. There is Redis AI, which basically gives you the ability to deploy models, AI models, and run inferences on Redis with the data that it's writing Redis. Also heavily used for feature stores. We have also Redis Gears, which gives you a Lambda-like environment where you can run functions against your data. Think about of much more advanced store procedures for the data that you have in Redis. So server-side computation. And finally, we have Redis Bloom, which basically extends that hyperlog with other probabilistic data structures that allow you to do very interesting things when it comes to big data, counting, and estimating. So the version of Redis that you want to use, if you want to get all of this, all the modules to get the goodness of basically all this diverse data structures and commands, it's called Redis Stack. Redis Stack bundles right now Redis JSON, Redis Search, Redis Graph, time series, and Bloom. And it's what I'm going to be using today to basically demonstrate some of the capabilities using Spring. So you can download Redis Stack from Redis.io. And there's many different ways to basically use Redis Stack. You can use a Docker image. You can use native installers, or you can also get a free account on Redis Cloud, which basically allows you to have a stack database. Will give you all those modules already pre-installed, pre-configured, ready to use. Today, I'm going to be using the Docker Hub, the Docker image. All right, so Redis really loves Spring. In Spring, the default de facto caching mechanism, typically it's going to be Redis. If you ask anybody that's deployed a Spring application, they're using caching, it's very likely to have Redis in there. So my My selling point here is that you already have Redis. Just make the Redis that you have better and fully use what you have in there. So let me talk about a little bit of the Redis client ecosystem and what we have to basically interact with Redis from the Java ecosystem. So we have a couple drivers. We have one called Redis, which has an appropriate Redis logo. And we have Redis, which doesn't have a logo as far as I can tell. And those are the two main drivers. There's also Redison, which is another very popular driver, but I did not have room to put it in my slides. So those are low-level drivers, libraries to basically talk to Redis, and they work at the command level. So you have your data structures, like let's say a string, and there's commands to basically put a string in Redis, remove a string from Redis, set the time to live for a string that you just put in Redis, things of that sort. Then for the modules, we have a family of libraries that were based on Redis to extend Redis with the commands that allow you to interact with the modules. And that includes, typically they're called JRedis something, JSON, search graph, gears, Bloom, time series, and JRedis AI. As of today, most of these are being merged into core Redis. So this slide's a little dated, but the work that I'm going to show today, it is based on these individual drivers. So that is all good and fine. You can basically work with most of the modules this way, but it is still very low level. It's command driven, so it's basically kind of a programmatic telnet for a specific feature. So the Spring team came up with Spring Data Redis, and Spring Data Redis allows you to map, to basically have a Spring Data project that basically sees Redis as a data source. And that includes just the regular caching, like the cacheable annotation, but it also includes mapping of data entities to Redis hashes. And that's what Spring Data Redis gives you. That and much more, streams and phantom keys, a lot of different features in there. So I needed to basically find a way to bring the goodness of the modules into Spring Data Redis. And the way that I went about doing that, it's to extend Spring Data Redis into a new library called Redis Own Spring, that basically provides high-level features to interact with the Redis modules. So I think I've spoken enough. Let's actually build something. And what we're going to do today, it's going to be a sample application that basically has no overall arching theme. I'm just showing all the features of Redis into a simple, small application. So first, we're going to start with basically what Spring Data Redis does natively, which is basically map a Java entity to Redis hashes. And then we'll see how Redis Own Spring extends that to have search capabilities on those. So that's going to be the Spring Data repositories that most Spring developers are familiar with, but they're going to be powered by Redis Search. Then we're going to show document mapping using Redis JSON and a native Spring Data annotation that basically allows you to map entities to JSON documents. We're going to look into a little more complex searching. And if time permits, we're going to look at an API for searching that we've developed at Redis called Entity Streams. And we're going to look at Bloom filters and how easy it would be to implement something like autocomplete in Spring with Redis. All right. In this application, I'm doing a lot of the data loading programmatically, mostly to basically show you what the data looks like and to minimize any conversions that I might be doing from loading JSON into the system. But if you wanted to do this in production, I recommend that you look at the tool called Riot that we also develop in-house that allows you to do basically rapid ingestion of data into a Redis database. And by the way, all the code for this can be found at my GitHub repository at the URL on the screen. and I will bring it back up at the end too. All right, so let me get started first. So Rebecca, could you please switch to the VS Code screen? Thank you. All right, so what I have here, it's my VS Code application, and I have, I have a little, I have a little Rust application that I use to basically play my repositories one commit at a time. So you can ignore what you're seeing on the screen at the bottom right now. It's just basically the ability for me to basically play through a repo of code. So the application that I'm going to show you started from the Spring Initializer website. So that's start.spring.io that most Spring developers will use to basically create the basic application. So I'm going to play my first commit, or my second commit, which basically brings my Spring Initializer application. So if you look on the screen on my Explorer pane, you can see that I have a typical Spring application. Let me maximize this so you can see what I have going on in here. Okay, so what you're seeing right now, it's the POM, the Maven POM for my application. And this was created with the Spring Initializer. I'm using Spring version 2.7, Spring Boot 2.7.0. And you can see right now that I have nothing but the Spring Boot Starter Web, the Dev Tools, and Lombok. And you can see here that I also have the Spring Fox APIs. Those are to basically have Swagger, so we can have a Swagger UI to test the application. We might or might not use it, but I always add that just in case. All right. So I have a very basic application with Swagger. And also let me show you the main Java code. So when you create a Spring application, you get a single Java file that basically has all of your code. So my Spring application here has Okay. My Spring application has the traditional Spring Boot application annotation. It has the enable Swagger. Typically, you have this main method at entry point to your Spring application. And here we have the docket bean that allows Swagger to basically scan your controllers and make them available on a Swagger UI. All right, so now we're going to add the star of the show, which is the Redis on Spring library. And you can see here that we have a couple versions old version of Redis on Spring. So Redis on Spring version 0.50, and that brings Spring Data Redis. Because remember, we're extending Spring Data Redis with extra capabilities. While we're here, we can also check that Redis it's running. So I'm going to quickly just run the Redis CLI, and you can see that Redis it's alive in there. I can ping Redis, and I get a pong back. So we know Redis is alive and kicking. I can also, we can do something interesting here. With Redis, you can run the Redis CLI in monitor mode. So I'm going to do that so I can actually see what happens. So if you see Redis here running in monitor mode, if I go here and let's say I ping Redis again, on the Redis monitor, you will see that ping that I just issued. So when we do some data mapping or object mapping from Spring to Redis, you should be able to see the equivalent commands that are being issued by the libraries to Redis. And also the search queries, which actually becomes a much more interesting premise for what we're doing. All right. Okay, so we have, now we're going to add a entity so we can map it. All right, so notice that we have only the demo application in our application Explorer. And I'm going to now add a basic entity. And now I have under my models hashes package, I have a role object that I created. So this role object, it's very simplistic right now. Notice that it just has an ID and a name. And we're going to decorate it with Lombok first so we can get getters and setters for free. So I'm using the data annotation from Lombok and the builder annotation from Lombok. We also going to add the Spring Data Redis annotation that tells that this entity should be mapped to a Redis hash. And that is Redis hash. For any data entity in Spring, we need to have a primary key or an ID. And we're going to use the ID annotation to mark our ID as being the ID of the entity. So that's all we need right now for basic storage of a role object that has two fields, ID and name, into Redis as a hash. We also want to add a repository. So in Spring, if you're familiar with Spring, there's the concept of a data repository, which is similar to, it's basically your entry point to do object-based operations against your data storage. So in our case, we have a basic interface called CRUD repository that gives you all the CRUD methods to interact with Redis hashes. So saving a hash, retrieving a hash by an ID, getting all the hashes, saving multiple hashes, deleting a hash, etc. So we're going to be adding a repositories hashes package, and under that we have a role repository. In the role repository, again, it's a very simple interface, has right now nothing inside of it, and it extends CRUD repository for the role object that we just created with a primary ID of type string. And notice that we have the repository annotation from the Spring framework. So this gives us now, and again, this is an interface. The environment will provide an implementation at runtime that we can use to manipulate this data in our application. So one of the other things that you need in most Spring Data projects is to enable those type of repositories. So one of the things that we're going to do in here, make this a little smaller, it's add an annotation that enables that type of repository. So in Spring Data Redis, we have the enable Redis repositories. Since we have enhanced those repositories with search capabilities in Redis on Spring, we have an annotation called enable Redis enhanced repositories to add those extra features into the equation. We also, since we're going to have a mix, we're going to have a multi-model application. That means that we're going to have some objects mapped to hashes, and later on today, we're going to have objects mapped to JSON documents. And to do that, we have to tell the Spring Data subsystem where the repositories for a specific data type are. So for our Redis hashes, we're going to tell it that they are under the packages repositories hashes for the repositories, and models hashes for the models that are going to be inspected. I'm also going to add a logger instance using this log factory, so we can basically output some stuff to the console once we get the application going. So Now, the first thing I'm going to do is load some sample data. So we have, what do we have right now? We have a role object map to Redis hashes. And we have the basic empty role repository that inherits all the CRUD repository methods. Now we're going to add a command line runner to load some data. So here's the skeleton for a command line runner. If you haven't worked with this before, it's a method that returns a command line runner instance, and it's annotated as a bean. So I could have done this as a separate class. And it takes a lambda, and inside of that lambda, you can basically perform operations that will happen on application startup or restarts. So the first thing I'm going to do is use dependency injection and pass one of the repository instances that we declare in role repository to my load test data method. So notice with method injection, I can just declare that in here, and by the magic of dependency injection in Spring, I'm going to get that instance of an object that basically fulfills the contract of the role repository. So notice in here, I have a logger message saying that I'm loading the test data. And then inside of my lambda here, that my return lambda, I am checking whether the repository is empty. So if it's empty, I'm going to populate it with data. If it's not, I'm just going to tell you, hey, it's already full of data. This is so as we make changes and the application restarts, we don't repopulate the database with new objects. Okay, so now we're going to use the Lombok builder method that was added magically to our role. That was this annotation right here, to create an admin role. So I'm creating an admin role, passing the name admin, very creative, and calling the build method. That basically gives me a admin instance. And let's just add a few more now that we know how to do that. So I have an admin, a customer, and an editor. And then I want to use the repository save all method. So I'm going to add all of these to a list. So notice in here, I'm adding all my roles to a list that contains now admin, customer, and editor. And now I can use that instance of the repository being passed, this role repository instance object, to save my roles. So notice in here that I can say role repository, save all roles. And I'm just logging a message saying here that I created an X number of roles. And here's an example of using the repository. I'm invoking the count method of repository, which is one of the things that the CRUD repository interface provides. So you get a lot out of Spring Data Redis out of the gate. And since we built on top of Spring Data Redis, we get all that for free. Okay, so if the roles table, we can call it a table, it's empty, or collection, it's empty, we add the data. If not, we're going to basically just do a loading of those roles. Since it's a small collection, I'm going to do a find all. That's another method that comes from your role repository. And I'm going to load that in that same roles list that I declare up above. And I'm going to just basically print the number of roles that are in the database. Perfect. So how do we do interesting things with the searching capabilities of the roles? So next, we're going to basically add search capabilities. But first, let me add the indexing annotation to the role. So notice that we have our role object, and I'm going to now add the first annotation, or the first actionable annotation from Redis on Spring. And this is the indexed annotation. And I'm adding that to the name. That means that when the application starts, it would try to create an index on Redis that basically indexes the role collection and adds the name as an index property. That means that we will be able to do searches by name in the database. Before, Spring Data Redis created a secondary collection, a set to basically maintain secondary indexes. Now, with a full-blown search engine under the covers, you can basically index any field in your collections and search by them without having to have extra data structures to maintain them. All right, so we have that in there. And to be able to do something interesting, now that we have the name index, we can go back to our role repository and add some methods that would basically do searches on our behalf. And if you've used Spring before, the repository concept is very powerful. What it does, it allows you to declare methods without providing an implementation, and the implementation will be provided for you based on the signature of the method. So based on the return values, based on the name of the method primarily, and the parameters. So in this specific case, find first by name says that I'm going to do a search over the roles for something by name, and I'm going to return the first hit based on that search parameter. And that's why we have an optional here, because you could find it or you could not find it. So it could be an optional that it's empty, or it could be an optional that contains the first hit that matches that name. All right, so now we're going to go back to the demo application, and we're going to add something so we can test that role find first by name. So notice in here, I added another command line runner below. And what we're doing in here is doing, I call it peek at the data. Again, takes the role repository being injected in there. And now I can say an optional of role, let's call it maybe admin. In that role repository, I'm going to do a find first by name, the method that we just declared on the interface, passing the admin string. And if it is present, I'm going to print the admin roles ID. So now with that in place, we can actually, let's go ahead and start our application for the first time. So I'm going to launch the application with the Maven command. I'm going to clean it. That's optional. And I'm going to run the Spring Boot run goal. So let me maximize that so you can see the application starting. And one of the things here is that we should see the application data being created for the first time. So notice in here we have we have here, that's clipping a little bit. Let me make this a little smaller. Yes. So notice in here we have the started. You can see that it created an index somewhere in here, where we can ignore that for now. But in here, said that created 3 roles. That's what we had in our application startup code. And it found the admin role, and that's the ID of the admin role. So to verify that, well, first we can see basically what happened against the database. Notice in here that we have a FT create. That's a Redis search index creation method. And notice that it created a index called the fully qualified name of our Java class plus IDX on a hash data structure. And all of our hashes have this prefix, as we will see soon on the Redis CLI. And notice that it created a field in that index for the name property. Allows us to basically do exact searches on that field, which is the tag type in Redis search. There's a few methods here for maintenance. Basically, there is a set of IDs that Spring Data Redis maintains. So this is what it's basically checking, that ID hasn't already been created in there. And here is the method that basically stores that Java object as a set. So this HM as a hash, sorry. So this HM set, it's basically adding a new role object with the ID that was auto-generated. This is a ULIT and the name admin. And you can see the same thing is going to happen for all the other customer and editor ID roles that we created. Then finally, when we do a search, this is the actual portion that it's interesting. When we do a search by name, this is the Redis search command that we are issuing against Redis. And noticing here that it has a syntax, for example, in here where you can specify the field that you're searching against. In this case, it's the name. And the value that we're looking for is at. Since this is a tag field, that's where you see the curly braces in there. There's different syntax for different data types. All right, so that is what happened against the server. Now let's take a look at what we have in the database. So if we run the keys command, you can see that there are 3 roles. These are the role objects that you have in Redis. So we can do HM get and pass that key. Sorry. One second. Yes, I apologize. So I meant to do an hget. Oh, hget all. Sorry, I blanked out in there for a second. Oh, when the Redis developer advocate forgets the command to get all the fields of a hash. So the hgetAll command in Redis allows you to retrieve a hash by its key. And if we, for example, do the type of that key that we were accessing, you can see that it's a hash. So here is how Spring Data Redis and Redis on Spring, by definition, store a hash in Redis. A hash that represents a Spring map object. And let me quickly do a check here, make sure that nobody is asking any questions on the chat. Oh yeah, there's some questions. Hold on, let me see. Oh, no, it's good, it's good. It's all us. All right. Okay, so we can see that we can map a hash, a Spring entity to a Redis hash, and we can do basic searches over that. Right now, let me go back to the code. And I'm gonna leave the application running. I might have to restart at some points and probably flush the database, but we'll keep it running for now. So I have now, so we have the basic role model. We were able to persist it to the database. Now we're going to add a new entity, and that's going to be a user model. So you can see here that a user model just appeared, and it's going to be similar to what we did with the role. Again, it's a entity map as a Redis hash, has an ID, but this one has much more interesting stuff inside of it. So I'm going to add the name for the user is going to have, instead of the index annotation, it's going to have the searchable annotation. And what the searchable annotation does, it gives you full search text capabilities over that field. Indexable on a string allows you to find by the exact string that it's in the content. Searchable allows you to do partial searches, fuzzy searches, wildcard searches, you name it. So for a string name, we have searchable. And then we also, in this specific entity, we have an email, we have a password that we have marked as non-null, just so we can actually have them in our builder constructor. We have a password confirmation marked as a transient, so we don't store that in the database. And we also have a reference to a set of roles. So now notice that we're basically doing a one-to-many, one user to potential many roles. And that's marked with the Spring Data reference annotation. So I'm also going to, since I want to basically put some roles in there without having to pass a new hash set to the roles, I'm going to initialize the role set right here on the empty constructor of user. So I'm going to say that the roles, it's a new hash set of role. So we can just add roles in there as we need to. So the other thing I'm going to do now is on the user object, one of the facilities that we added in Redis Home Spring, it's the ability to add audit fields. So I have two audit fields here. We have a created date and a last modified date annotations. And by providing two date fields, it can work with a lot of different of the date or timestamp fields in Java. In this case, I use dates. And what's going to happen is that on the creation of the object, we will basically put a timestamp on created date. And on each modification of the object, we will populate the last modified date. And by we, I mean the framework does it for you automatically. All you have to do is declare them in here. All right, so now, since we have a user entity, we also have to add a user repository. So I'm going to add a user repository. And the user repository, you can see here that, again, extends CRUD repository. Very, very simple. And back in our demo application, let's add a skeleton to basically load some users. So notice in here, I'm going to do the same thing inside of my load test data. I added another block of code where I basically check if the user repository is empty. And if it's, one of the things I'm adding right now too, it's if you look at my resources folder, I added a file, a JSON file that basically contains a bunch of sample data. So notice that my sample data, it's a big JSON array that has JSON objects with password, name, and email. So that will come into play in a second. Also, in my user object, I'm going to double dip and show you another feature while we're here. And I believe, yes. So notice that we have an email field. And one of the typical things that might happen in an application when it grows very large is that on registration of your web application, you would have to check whether an email has been already taken by a user. And if you have, millions, or let's say that you're super successful at Facebook and you have billions of users, then that query actually might take a significant amount of time. And it might slow down the sign-up process and also impact other parts of the system. So in Redis, we have a data structure, which is a probabilistic data structure called a Bloom filter. And in Redis on Spring, we have an annotation that allows you to create a Bloom filter for a specific field. So in this case, I'm creating a Bloom filter for the email, which will allow me to basically ask the question, has this email been taken? So let me go now back to the demo application. And in our load users block, I'm going to create some users. So notice in here that to do that, what I'm going to do is basically use a buffer reader to read that JSON file. And then I'm going to use JSON, the Google JSON library, to basically map those JavaScript or JSON objects to our user objects. And then I'm going to, one by one, save them to the database. So obviously, this is multiple calls to save. Typically, you would want to do this in some kind of transaction or a pipeline operation. I'm just basically doing a very, very inefficient way to basically store the data. And like I mentioned, we have the tool Riot that it's designed specifically to do this type of fast data ingestion. What I'm doing in here is just for demonstration purposes. So I'm streaming over the users, adding a role. So I'm getting a random role from our collection of roles and setting that role onto that new user, and then using the user repository to save the user. And then it's going to tell us, it's going to tell us how many users have been saved. So what I'm going to do now is I'm going to go back to the Redis CLI and remember that we had, let me maximize this for a second. Remember that we had a few hashes in there, but now the application restarted and reloaded a bunch of stuff. So I'm going to basically flush all and start cleaning here. What I'm going to do is go back to, let me clear that. We can check that there are basically no keys. We have an empty database. I'm going to go back here, and I trust that I did it all properly, but I'm going to restart it just to basically see it, everything clean from the start. So this should basically create our roles, create our users. It should also create our probabilistic data structure index, our Bloom filter index. So notice in here that, let me see if I can make this even a little smaller. There we go. Okay, so we have created an index. We found 2 Redis hash annotated objects. We found a searchable annotation, a Redis hash annotation, an index annotation. It created 3 roles and 1,000 users. And it still was able to find that role that we created before. And if we look at our Redis CLI monitor commands, we should be able to see that we created, obviously, a bunch of those hashes are going to be created. But I wanted to highlight this. This bf.add, that's us adding that email, this email, to the BF company email Bloom filter that was created by the annotation. And the Bloom filter takes a fixed amount of storage, and it also takes a fixed amount of time to ask the question, was this email added to the Bloom filter? And that is the ability to basically store, potentially billions of items into this collection and ask the question, tell me whether this item is there. In being probabilistic, a probabilistic data structure, there's a chance that the question might not be accurate, but that chance it's minimized, and that chance is configurable too from the annotation level. All right, so let me now go back to So I'm going to go back to the annotation, to the code, and on our user repository, let me show you some of the things that have happened in there. So in the user repository, we have nothing specific in there. So I'm going to now add a more interesting method. So remember that we have in our user object, let me bring that guy back up. In our user object, we have the name annotated with searchable. That means that we can do a full text search over that specific field. And the Spring Data repositories allow us to do that by using things like the find keyword by the field that we're looking for. And here's where we can do full text search type of searches. So one of the ones available, one of the predicates available, it's starting with. So I can say find by name starting with, and passing a prefix, and it's going to basically return a collection of users. So in our demo application, I'm going to, once again, in our peek at the data, I'm going to add a block here that's going to say user repository, find by name starting with, and the prefix is going to be MIC. So any Michaels, Michelles would basically be caught by that specific query. And then we're going to just loop over that collection and just print the names that we found, all right? So since we have the application in auto restart mode, this should have happened already. So let's go to the Java here, and let me maximize this. And you can see here that the parameters for that search were MIC. And you can see here that it found the username Michelle Young, Michelle Olson, or Michael Olson, sorry, Michelle Sims, and Michelle Dixon. If we look at the Redis CLI monitor, we can see the query that was used to do that. So it's probably down here at the end. Yes, so here is the Redis search query that basically did that. And you can see here that it's an FD search. Here's the prior method that we have to find the role by name. Notice that for those tag, that indexable field uses a curly bracket. For our full text search, uses the name in just the search string with an asterisk after it. So very similar to a SQL query. It just takes a little bit of time to get used to the syntax. But again, since we're mapping everything on your behalf, you don't really have to know the syntax of the search queries, but you can always go and verify that what happens is what you intended to do. All right. Okay, so let me see where I'm going next. Okay, so if we look at the user object again, now we also added an index annotation to the email. And I should probably drop the user index so it can get recreated. That's something that I did not. So let me do that quickly here. So I'm going to flush my database again, just to make that easier on myself. And I'm just simply going to restart the app. So one of the things that we do not do is, if you have already created a search index for an entity or for a collection, we don't destroy it and recreate it on your behalf, because that it's a potentially costly and damaging operation if somebody accidentally does it in a production environment. So we are basically putting the responsibility of dropping an old index so it can be recreated on the user for now. We are in design talks to talk about basically how to do index migrations from the application point of view, but that's neither here nor there yet. All right, so okay, so in our user repository, we have the user find by name starting with. Now we can do other interesting searches in there. So I'm adding a find first user by email. So notice, since we added the index annotation to the user, we can now do to the index. Oh yeah, right here on the email, there is the index annotation on the email. So now we can do searches like find first by email. So in our demo application, let's test that. So right here in the same code that we had, oops, I'm going to now add a little block of code to test that. So in this one, I'm basically creating an optional of user called maybe Roger, and I'm going to do a find first by email, passing the email rogergreen@example.com. Notice that I'm escaping the special characters in here in this case. This auto escaping, it happens automatically now in newer versions of the library. I just don't happen to have that one on this repository. So if we switch back to the application, you can see that it blew up. So let me see why. So I'm gonna close it. Let me make sure that I did not break anything. Typically, the live demo gods can get angry at me, so I'm going to just restart it. And let me maximize this so we can see what's going on. We are getting close in time here. I think I'm gonna cut it at an hour. So we definitely did not get to everything I wanted to do, but pretty close. So notice in here that, let's see, found, started. Oh, no, something that, you gotta love it when you break something at the last second, huh? Oh, I broke something on that command line runner. Okay. All right, let me move on. Okay. So in my system, I'm going to add now a fictional character JSON model. And let me show you what that looks like. Oh, sorry. I added an address object. Now we're going to move to JSON. And assuming that I did not break anything else. So, all right. So we have under our models hashes, now I have an address object. So this is a simple object, again, marked with data. Notice that I have an index, house number, a searchable street. You can basically do things like tell the index creation code to not to stem that specific field. So I'm saying I'm passing the no stem clause to the searchable annotation in here. I have a city, state, postal code, all in country, all marked with indexed. And then I also created a fictional character class that basically has, again, an ID that happens to be indexed, a actor first name, actor last name, the age of the actor, so you can actually index numeric fields. The index annotation is smart enough to look at what your data type is and create the correct underlying index. I also have the searchable annotation on a quote from that actor. And then I have the a point class, which basically tells us where the actor location happens to be. That's also indexed. This is a geolocation from the Spring Framework. So you can annotate geolocation coordinates with index, and we will create a geo index on your behalf. And then we have actor address, which is going to be a full-blown object. Notice that you can actually index a full-blown object that it's a property of one of your objects. And you can also index a set of, in this case, strings called skills. All right, so we have our fictional character, we have our address object. We're going to need a repository. So in our repositories, notice that we also have our JSON repositories here. So I have a fictional character repository. And notice that that extends a different interface. This is the Redis document repository, which happens to be a JSON-specific document repository. Oh, and there's a question on the comments whether there are .NET 6 examples, C# examples. Yes, there is a Redis own .NET library that is also maintained by Redis, and it's very similar to the Spring version of it. So yes, there's there's a .NET version of this mapping facilities. There is also Python and JavaScript available. All right, so there's my fictional character repository, and I'm going to add a few methods in here. So there's the find by the actor age between, so I can do range searches on a numeric field. So notice in here that I basically can pass a min and a max. I can, and let me maximize this so we can actually see this a little better. Okay. So I have a find by actor first name and actor last name. So notice that you can do compound searches using the and word. So you can target two specific fields, actor first name and actor last name in this case, and pass the two parameters, and the system will basically know how to glue all this together into the appropriate search query. Add a bunch more in here. So this, it's a geo search. So I'm saying find by actor location near a specific point, and then you pass a point that you're basically centering your search, and a distance radius to basically do the search. And you can also do a full text search by any of the fields that are marked with the searchable annotation. So in this case, I'm going to do a search by the quote field. So if you remember, if we go back to our fictional character, I think I closed it. Yeah. If we go back to our fictional character, we have our quote, which is searchable. Therefore, in our repository, we can do search by quote and just pass a string of text. Finally, when you have an embedded object, for example, in our fictional character repository, fictional character entity, we have an address object that happens to have a city inside of it. So if you remember, we have the fictional character, we have an address called actor address, and in that address, we have index fields. In some of them are street, city, state, things that you expect to find in an address. So in our repository, we can do find by actor address, and then you use an underscore to navigate to that lower level object or to that embedded object. So in this case, we're going to find by actor city. And also, the tag searches allow you to basically do searches based on a set of values. So for example, our skills, it's a set of values. So we can pass a set that says, find the characters that have one of the skills passed in this set. And you can also tackle the containing all predicate to a search like that, and then say, and turn it into an and search, basically saying, find a fictional character that contains all the skills being passed in that set. So finally, since we have that object, a couple of objects that are nested, we have a repository. Now in our main application, we also need to tell the system that we want to be able to use document repositories. So just like we had an enable Redis enhanced repositories, we need to add enable Redis document repositories. And similarly, we are passing the packages that contain the domain objects and the repositories. So now I'm going to load some of that fictional character data. And down below here, I have another block where I have, and I pick Marvel characters because my kids love those movies, and I do too. And I just pick a few quotes from IMDb to basically put in the quote text to do the full text searches, a few addresses that I made up. And notice that all the addresses have a geolocation. Let me see if I can find what my geolocation is. Oh, sorry, the geolocation, it's at the fictional character level. So we have 6 fictional characters. And notice that they have ages, specific geolocations, and set of skills. So for example, here, Thor has a hammer, biceps, hair, and heart. Doesn't say much for him, but he has evolved over the course of the movies. So I'm doing a save all on that fictional character repository. And next, we're going to add a controller so we can do some searches. And I'm just going to show you the code for this. And I'm not going to run it because we're running out of time. But you can actually get access to the whole system on GitHub. And it's very easy to basically get it going locally. So the in my controllers folder, which I don't see here yet. Hold on. Oh, sorry. Yes. So here's my controllers, and I'll show you basically how you would use this from a controller in Spring. So we have our repositories with our very flexible search methods declaring there. You didn't have to implement any of them. Basically, all you have to know is how to declare them. So knowing those predicates becomes a little bit of an art, but I have a cheat sheet that actually I look to basically figure out how to construct those method names. And once I have them, they typically work out of the box. So in a controller, I have a REST controller mapped to this API RDC endpoint. And in here, I'm auto-wiring my fictional character repository. And you can see that I can do things like find all the characters. In a big data scenario, find all might be very dangerous because Redis is meant to store millions, if not billions, of entities. So you want to be careful with that one. Here is basically one to find character by ID. This is built into the CRUD repository, so you don't have to declare it in your interface. But here's some of the ones that we created ourselves. So here's basically find by the actor age between a min and a max. And my repository, my controller method basically takes those two values. The request param will parse them correctly into this int. And then all I have to do is basically pass them to my find by actor age between. That's going to return JSON that is going to be basically transformed all the way out into JSON again when you get your list of fictional characters. Same thing happens to basically every method that we have in there. For example, find by first and last name, find by home location. So basically, this is how you would build a very fast, very flexible service or web service using Redis as your backend. And obviously, this will be pretty fast because there's no physical disk that you would be hitting. You're basically getting it from memory, but that data could be persisted. As I mentioned before, you can set your Redis to optionally persist the data. And then you basically have a database. Therefore, your cache has become your database. So I'm going to close right there. I mean, you can see that the searching capabilities are as flexible as what you could do with SQL queries, but simpler, and are similar to what you could be doing with any other full-blown search engine. It just happens that you're working in the language of the environment you're working in, which is in this case Java and Spring. All right, so I'm going to open it up for comments since I'm running a little late. And Rebecca, if you have any questions that you want to pass on, I could address them now.
Wonderful, thank you. So it seems like the audience didn't have too many questions. We can definitely give them a few seconds to kind of see that it's the end of the session and potentially reach out. In the interim, I'll just quickly do a little plug here. So thank you again, Brian, for this, by the way.
You're welcome.
That was great. And I appreciate you taking the time out of your day to put this together for us here at the Reactor. For anyone tuning in that hasn't been a part of the Reactor before, if you happen to stumble upon us on YouTube in a search or something, we have a full calendar of events running virtually and also in person at our 12 physical spaces around the world. So definitely check out our meetup calendar, find a location closest to you, time zone that works for you, and keep an eye on it. We're always updating. Our regular registration webpage will be back up and running probably in the next month or so, or in a couple of weeks. So looking forward to that. Yeah, I think I'm just keeping an eye on the chat here, and I'm not seeing any additional questions come through. So I think over time,
can I switch it back to the slides and just give a few closing comments in there? So here are the links, and I believe Rebecca just posted them back onto the chat. Remember that I'm assuming that being a Microsoft forum, we have a lot of .NET enthusiasts. So we have a Redis-owned .NET library that is actually very powerful. And you can do everything that I've shown you here, but in a .NET flavor. We also have Redis Cloud, so you can try it for free if you want to do any of this stuff without installing Redis locally. And I put a coupon code in there if anybody wants to basically get the full-blown experience. And we at Redis have a bunch of articles about all of the stuff that I've shown today under the developer.redis.com. And we also, the DevRel team at Redis, we run Redis University. So if you want to get your big data and your Redis knowledge up to date, we have a wonderful collection of courses there. So yeah, thank you guys.
Thank you so much. Everyone, take care. Thanks for tuning in. Have a good one.
Bye.
Bye.